So now I'm going to answer some questions. The first question I'm going to answer is why I'm not using an augmented magnetic field. Well, so as you can see is I have almost 100 kiloamps going through the rails, but that's of course an ideal situation, which is not. Instead, I'm going to round it to about 70 kiloamps, and I'm going to try and calculate what the magnetic field is and why I'm not using an augmented magnetic field, and it's going to be pretty clear why not. So I'm going to calculate what the magnetic field is. Well, the formula for the magnetic field is mu naught I divided by 2 pi r, or 2 pi rho, as I explained in my previous video. We are going to, the mu naught is 4 pi to 10 times the power of -7, that's mu naught. The current I'm going to round to about the ESR of the capacitors per capacitor, but I have 6 in parallel. So it's going to be around 66 kiloamps, and we are going to divide it by 2 pi. Oops. 2 pi, and the distance from the projectile to the center of the core of the magnetic field, which is going to be a rough estimate, but I'm going to assume it's about 0.1 millimeters. So that's going to give us a magnetic field of 132 teslas. That's tremendously big, but this is for an ideal situation. It's going to be probably a bit lower than that, but still a normal neodymium magnet will produce a magnetic field of something maximum to 1 Tesla. So there's no point in adding the extra mass, as the electromagnetic field produced by the current is way higher than a normal permanent magnet. The second comment I'm going to discuss is why a circular barrel and not a square barrel? Well, it's very simple, because projectiles are most effective when circular, and to have the maximum connection between rails and projectile, it's going to have to circular as well. And the comment was that it's going to be pretty hard to make a circular barrel, and that's kind of true, but I'm not intending on making it perfectly circular. I'm going to just kind of mill out the inner portions with of a bar, a square bar, and that will just fit inside the rail gun itself. That brings me to another idea for a project for this railgun build. That is going to be a kind of mill with a rotary axis, so it has 4 axes, and I'm going to try and design it myself on my own. What my plan is with it is, for example, this is the rails and this is the milling bit, and it will just mill out the portion, so we have a circular kind of concave inside of the rail. So it will be almost extremely precise when it comes to fitting the projectile inside the concave. This brings me to the next comment, which was about helical rails. It was a suggestion for helical rails and the effectiveness of helical rails. It's really hard to make helical rails without CNC and a lathe and a mill. So with this I'm going to try and design it as good as possible, so it can function as a mill and a lathe at once, because it's 4 axis. So I will have to make a gearbox and all that stuff, but more on that later. The next question is about the recoil in the railgun, because there's a huge amount of energy released at once, and that would theoretically have a huge recoil overall. And yes, there is a pretty huge recoil, but as you saw in my last video, if my fingers represent the rails, there will be a huge magnetic field, as you saw, about 100 Teslas, and they will be repelling each other. They will be going outwards instead of in a conventional gun. The energy is produced by an explosion in the barrel itself, therefore you will have a recoil everywhere, and most of it is directed parallel to the barrel, but in this case it's not, because the recoil does not interfere with ourselves, so therefore the recoil is only in the opposite direction or perpendicular to the rails. Most of the recoil will be where the magnetic field strengths are the highest, and I have kind of plotted here where that will be. As we can see here, this is the differential equation for the current that will flow through the rails, and as you can see, the X represents time and the Y will represent the current. Therefore you can see it drops almost instantaneously. Well, that's a huge amount of energy. So if we can zoom in, for time is 0 to 3 tau, which is about 3.04 to the minus 4, about 304 microseconds, and the current is huge. It's about, let's say, 100,000 to 0. Oh, 100,000. I hope we have a curve. We don't have a curve. Okay, there we can kind of see the current. Okay, right. If this represents time, it's more clear this way. Therefore, here the magnetic field strength will be the highest, which is almost instantaneously when the projectile enters the barrel. Therefore we must create the structure there insanely strong, and I'm probably going to calculate a little bit of that in this week, or perhaps not far in the future, but I'll start designing the structure which will support it. And if we can see what the current will be, which is almost, according to this, no, you can see for yourself, which is not the value I calculated, but this is about it's not pretty accurate, but you can expect a current more likely in this scenario than 100 kiloamps or something like that. Also, a quick little comment. As you saw here, I made a little mistake. I didn't take the cross section of the curve and the y-axis, but here it is, it's at 0, but it's 301 kiloamps, and that's of course ridiculous. But I haven't taken account for the resistance of the projectile, because it has to be conductive as well, but it has to be rigid, so it will have a likely resistance way higher than the rails itself. Also, quick thank you to everyone who has commented on my videos and watched it, and that you are genuinely interested in the project. I really enjoy reading all your comments and answering them. That's the kind of thing that makes me motivated to make more and speed up the project, so you can see the end result and see how great it's going to be. So as I said, this week I'm going to start building the power supply and designing the control system for the power supply and programming the microcontroller. And my question was if anyone would be interested if I live stream the building and prototyping process, and if you would watch it or not. If not, I won't do it. And perhaps that's a good idea, but I'm not sure because my internet is not the best. So leave a comment in the comment section. Tell me what you prefer, if you want to see a little bits of the build and then in a video, or have me live stream the entire thing, or yeah, that's basically two things you can choose. So either video or live stream. Of course, a live stream won't replace the video for next week I have planned on the power supply build. It's going to be different parts because I've never built a power supply before, and it's going to be interesting, especially this one, since I'm going to do stuff that's never even been done before. For example, voltage doubling with MOSFETs, 0 voltage switching even on top of that, and I should get a Frankenstein power supply, but it should be, I expect something in the 90% efficiency, but of course there are going to be struggles, and if you like to watch me struggle, that would be a live stream place. But yeah, just tell me if you think it's a good idea, and I will see if enough people are interested in seeing that.